Hey. All right, I'm starting. So anyway, 8.4 is solving logarithmic equations. Again, yesterday we learned what a log equation was. Today we're learning how to solve a log equation. So if a is a positive number other than 1, meaning the base is something other than 1. By the way, it also has to be positive. The bases are not allowed to be negative. So then the log and base b of x is equal to the log and base b of y if and only if x equals y. So what that is intending to imply is that if you have a log in the same base equal to a log in the same base, you can drop the logs and set x and y equal and solve. Okay, so that's one of the methods of solving these, but it's not the only one. So this one is not log on each side. This is the original equation. Definition of a logarithm, you can rewrite it as an exponential. So the base was 2, the exponent was 3, the answer, and you set them equal. So 2 to the third equals 2x. I usually go 2 to the third equals 2x out of a different order than this one does. Not that it really matters. I don't know why I tend to like it to do it that way, but that's just me. 2 to the third is 8. You would divide by 2 and get x is 4. The second example shows that you have logarithms in the same base on both sides. So since the bases of the logarithms are equal, you can drop the logs. They must be equal. This x plus 17 must equal the 3x plus 23. So solving that, you would subtract x from both sides. You'd be at 17 equals 2x plus 23. You would subtract 23 from both sides, get negative 6 equals 2 times x. And then you would divide by 2 and get x is negative 3. Okay, so those are those two examples. Now we're going to do, of course, some more. So we're going to solve each equation. When in doubt, rewrite as an exponential if you're not sure what to do. In this case, 2 is the base, the exponent is 3x, and it will equal 32. So rewriting it, I usually do base to the exponent equals the number there. They were suggesting in the box that shows the definition or the basic rewrite of the logarithm as an exponential, they were saying 32 equals 2 to the 3x. It doesn't really matter which side this is on, okay, to solve it. But what am I going to do to solve this problem? Oh, rewrite 2 to the 5th, rewrite 32 as 2 to the 5th. So I'm going to replace 32 with 2 to the 5th. And some of you need more practice with this idea from looking at your quiz 1. The bases now match, so you can drop the bases and set the exponents equal to one another. So 3x has to equal 5. Dividing by 3, you get x is 5/3. Okay, number 2. The base is 3, the exponent's negative 2. So 3 to the negative 2 equals 2 times c, or vice versa. Not really bothering me which way. If you want to do 2c equals 3 to the negative 2. The next step would be to evaluate 3 to the negative 2, which is 1 over 3 squared, or 1/9. Okay, now some of us have still had some issues with what to do right now when I have divide by 2 is what I think a lot of you think right now. And then if you give me an answer, 1/9 divided by 2, I'm going to say no. And I won't let your answer look like that. So what could you do instead? Pardon me? Flip what? Multiply by the reciprocal, or do you mean this part? Are you looking up here to decide what to do, or are you looking at this again? Not a negative 1 for an exponent. I'm right here to get rid of the 2 to solve for c. You could just take 1/2 of both sides. Now that is the same as dividing by 2, but it's multiplying by 1/2. That's what I was hoping to get from someone. I think somebody said that, right? Multiply by 1/2. Okay. Now when you multiply 2c by 1/2, of course you end up with c alone. But what happens when you do 1/9 times 1/2? 1/18. Numerator times numerator, denominator times denominator. I just still have some students who are really struggling still with fractions. 1/9 divided by 2 really is 1/9 times the reciprocal of 2, which is the same answer we just got. Okay, so I don't know who was thinking what. But anyway, this one, I'm going to do 2 to the negative 2, 2x to the negative 2. I'm going to put that in parentheses, equals 16. Well, ideas. Simplify this to 2 to the 4th. Okay, we can do that. That is a way. All right, since you suggested that, I will do it that way. I showed it 2 ways, second hour. 16 is 2 to the 4th. Now, what? So you said do that. I'm just wondering if that's going to work. Oh, do what? So do 2 to the negative 2, x to the negative 2? Is that what you're saying? Well, I'm not saying this is exactly what I think we should do. Okay, so, all right. I just don't see this going anywhere. Do you? It's kind of looking hard, doesn't it? Look a little weird. So when that happens, and I went with it because I wanted to see, you know, what you were thinking, and then this is definitely a way that you could start a problem. But if it doesn't seem to be working, maybe you should start over. Okay, this isn't how I did it second hour, but I did do something like this. Now, I'm going to erase the green part because changing this to 2 to the 4th wasn't helping us. All right? All right, so let's stop and look back at where we started with the first step. Now what could we do differently? We can't divide by 2 yet because that's in there. Okay, you could take both sides to the reciprocal power. All right, or, and I'm thinking more people are going to see this. Brooke, I'm not dismissing what you're saying. I'm going to come back and tell you that way the second time, okay, when we get a little further in. All right, I was thinking, why don't we rewrite this? I think most of you might have been thinking like that, maybe? No? Because you got to get rid of the negative exponent? No? Well, that's what you're supposed to know about exponents. So if I square this now, that's going to be 1 over 4x squared equals 16. How can I solve that? Cross multiply. All right, this is, again, this isn't the only way. I'm going to go back and talk about what Brooke suggested in just a bit. 4x squared times 16 would be 64x squared, and that would equal 1 times 1, which is 1. We would then divide by 64. X squared would be 1 over 64. And then we would take the square root of both sides, which would give us plus or minus 1/8. Now, we got to check if both of those answers are viable, if they're good answers. Because I know you guys are thinking, why wouldn't we have plus or minus? Well, we don't, actually. It's only going to be the positive one, and let me explain. In the new, you see the base? If you put a negative in there for x, you're going to have a negative base, and the bases are not allowed to be negative. Okay? So there is an extraneous answer. The only answer is positive 1/8. Okay, now, I know that was a kind of a lot of space there for that one. You took up a lot of area of space. I'll come back and revisit that other way in a few minutes after we get to where we got some more room. All right, so let's just go over to number 4, please. I'm going to say x over 2. Again, it doesn't matter if you start with that and then do the base is 25. The exponent is 1/2. What does it mean to, and I'm trying to be inconsistent, these are interchangeable on either side. What does 25 to the 1/2 mean? The square root of 25. Good. All right, so x over 2 equals 5. And now we just multiply both sides by 5, and we get x is 10. What did I say? Oh, darn. Multiply 5 by 2. Multiply both sides by 2. No, sorry, I wrote the right answer at least. I didn't do that bad of a brain cramp. All right. My brain, I was getting distracted by someone in the room, actually. I was distracted. All right, ready? Now, again, we don't have logs on both sides, so we have to work with the exponential, rewriting it exponentially by definition of a logarithm. So 5x plus 1 You can start with that part, equals the base of 4 raised to the second power. So this is a nice simple one. 5x plus 1 equals 16. Subtract 1 from both sides and divide by 5, and we end up with x is 3. Okay, I'm going to start that one the same way. Whatever's right here, x minus 5 will equal the base 8 to the 2/3. All right, now wait a minute. What's 8 to the 2/3 equal? How do you know it's 4? So someone else in the room is probably saying, I don't know why that's 4. What's the that is not the answer I want to hear. I do not want to hear the answer. You put it in the calculator. All right, what I really want is your understanding of what these numbers are doing, okay? The top number is a power, the bottom is a root. Remember our rational exponents? So that means the cube root of 8 squared. All right, I hope you remember that. Cube root of 8 is 2. 2 to the second is 4. So that's why it's 4. All right, without a calculator. And then we add 5 to both sides to get x to be is 9. Oh, I wrote 5. I don't know why, as I said the word 9. Uh-oh, something's wrong. Maybe I need some vitamins. Cup of coffee, something. All right, here we go. 7. Ooh, look at that one. Take a gander, think about it a moment. Do you know what this is? What's the answer to this part? 3 to what power is 243? All right, so in your heads, 3 to the first is 3. 3 to the second is 9 times 3, 27 to the third. All right, 3 to the fourth, 81. Then 3 times 81 is 243. So it's 5. All right, so x minus 4 is equal to 5. And then we get x is 9. Okay, so with that in mind, go over to the right side of this one. 6 to what power is 216? That's your thinking bubble. 3? Okay, so 3x equals 3, and x is 1. All right, number 9. Now we have logarithms on both sides. We're going to finally get to use that rule that says if the log in the same base equal to a log in the same base, drop the logarithms and set these equal. So we get x squared minus 6 equals 2 times x plus 2. What should I do to solve this one? Do what? Oh, what's that going to do? Give me x squared equals 2x plus 8. Get it set to 0, people. It's got quadratic. So how are we going to solve it if we can? The easiest way to solve it is factoring. Unless you can't factor it, then you move on to the quadratic formula or completing the square. All right, I'm going to do factoring. That's x minus 4 times x plus 2. All right, so we get two solutions, x is 4 and x is negative 2. However, when you get a quadratic and you solve and get two solutions, you better check the solutions. You really should check them anyway, especially when x is in here, because this can't be a negative number. So if you put in negative 2, you would get a negative number on the left inside here. And if you put a negative number in the negative 2 in here, you're going to get a negative, and that does not work. All right, can't have that. So you have to eliminate this extraneous solution. And the answer is only 4. All right, number 10. We don't have a logarithm on both sides. So we're going to have to rewrite as an exponential. Base of x plus 4. The exponent is 3 on that, and that equals 27. Okay, what do? Gotta undo that cubing. To take both sides to the what? Well, you said cube root, which is the same as the 1/3. Okay? Reciprocal exponent. All right, 1/3 times 3 is 1. And we got x plus 4 equals the cube root of 27 would be 3. And then subtract 4 and we get x is -1. Now, let's double check that that's okay in the original equation. So put in -1 here, a base of 3. Oh, that would make everything perfectly fine. No problem with the -1. 11, logarithms are the same base on both sides. Drop the log. Look out for your toes. Dropping logs. Logs are heavy. Okay, subtract 2x from both sides. Failed to see the humor in that, apparently. Add 1, we get 4. Madeline laughed. Sort of. Sort of. All right, got x is 4. 4 seems to work in there just fine. All right, now your assignment, which you picked up on the desk, was pages 504 to 507, and these are the problems. I've already put them in. Hey, make a note that where it says in the middle of the first page, it says 8 through 18 evens. I wrote down 2 evens. That didn't mean go to the back of the page and still just do the evens. Do you follow me? It's only for the 8 through 18. On the first page of the worksheet that I gave you where I printed out the book assignment, it's the evens on the front page from 8 to 18, right? Not the ones on the back. You want to do all of the back. But it's right there for you. Should you have time now to work? Just so you know, tomorrow also is going to be a question and work day. I'm going to stop now with recording and have a great day. Get to work.